In this video, I'm going to be introducing the concept of drawing lines using equations. So we're going to start with one type of equation that we can use to represent a line. It's called slope-intercept form. The reason it has that name is because in the equation, we're going to be giving the slope value and the y-intercept value. So that's why it's called slope-intercept form. Here is the slope-intercept form. It looks like y equals m times x plus b. The y variable is going to represent the y coordinate of any point on the line, as is this x variable. That's going to represent the x coordinate of any point on the line. So together, they give you a coordinate pair of any point on the line. M is going to represent the slope value, and the y-intercept is going to be represented by the variable b on the end of the equation. Let's see how it all works. First, let's talk about what a y-intercept is. What is this b being represented? A y-intercept is where the graph or the line crosses the y-axis, or it could just touch the y-axis. When you get to more advanced math, it may just touch the axis. But for our purposes, we'll see it go all the way through the y-axis, so it will cross it. That point, or that coordinate, is called the y-intercept. When we write a y-intercept in coordinate pair form, we're giving the x and the y value at that point. And if we're on the y-axis, the x coordinate will always be 0. We haven't gone left or right, we've just gone up or down. So the x coordinate will always be 0 in this coordinate pair, and the y value will be whatever value the line is crossing. So here the line is crossing the y-axis at 2. So we're going to say our x value is 0 and our y value is 2. There's our coordinate pair, or the y-intercept. Likewise, an x-intercept is the point where a line crosses or touches the x-axis. And in that case, the y value is always going to be 0 because we haven't gone up or down. We've just gone left or right. So in the coordinate pairs for x-intercepts, the y value will always be 0. The x value will be the point wherever the line is touching or crossing. So in this example, it's touching or crossing the x-axis at positive 5. So I say my y value is 5. Sorry, my x value is 5, and my y value is always 0. So the first thing we want to be able to do is just look at an equation in this slope-intercept form and be able to state the slope and the y-intercept. We're simply just looking in the right spot and writing the value. So if I want to find the slope of this equation, I'm looking for that value in front of x, where that m should be, and we're just stating the value. So the slope is negative 1/2. That means it's going down 1 and to the right 2 spots. And then the y-intercept is going to be whatever's in place of that b value, and we're going to put it in coordinate pair form where the x value is always 0, and the y value will be whatever this value is, 5. So again, one more example. The slope is going to be in front of x. It doesn't include x, that's the x coordinate, it's just the value in front, it's that coefficient. So the slope is negative 4, or negative 4 over 1. And the y-intercept is going to be this value. So we're going to include the negative sign that's attached to the value. So this y-intercept is negative 10, and in coordinate pair form, it would be 0 comma negative 10, because that x coordinate is always 0 for a y-intercept. So it's a little bit easy if it's already in that slope-intercept form. You just got to look in the right spot, state the value. What if it's not already in slope-intercept form? Well, what we want to do is we want to solve it for y. Notice that these equations are solved for y, and then we want to put it in the order of slope-intercept form. So we're going to put that value attached with x first, and then that value that doesn't have a variable, that y-intercept value, or that b value, is going to be last. So if we solve this equation for y, we're just going to subtract 2x from both sides and put the negative 2x in the mx spot of our equation, and put that positive 6 shifted over to the right. Because it's positive, we're going to put plus 6. And so that's going to represent our b value, or our y-intercept. So now that it's in slope-intercept form, we can state the slope, it's negative 2, and the y-intercept is 0 comma 6. Let's try one a little bit more complicated. If I want to solve this for y, I'm going to subtract that x term first, subtract 1/2 x from both sides, shift that -8 to the outside. So now we have 4 times y equals -1/2 x minus 8. To get y by itself, we're going to divide by 4, which is the same as multiplying by 1/4. And that might be a little bit easier than dividing by 4. We got to do that to every single term here. So if I divide this by 4 or multiply by 1/4, I just get y, which is what I wanted. If I multiply this term by 1/4, then I have 1/4 times -1/2. Multiply the tops, I get -1. Multiply the bottoms, I get 8. So -1/8 x is that term. And then if I multiply this -8 by 1/4, I'm really dividing by 4. So 8 divided by 4 is 2. And it was really a -8, so we say -2. So now we got our y-intercept form. Our slope is attached to x. It's -1/8. And our y-intercept is going to be 0, -2. We got a couple of special lines, our horizontal and vertical lines, that have special equations. A horizontal line is always going to cross the y-axis. So we write its equation as a y equals the y-intercept equation. We learned in a previous lesson that the slope of a horizontal line is always 0. It doesn't go up or down, it stays flat. So it doesn't incline, it doesn't decline, it has a 0 slope. The y-intercept is always going to be where it crosses the y-axis. So a horizontal line is always going to do that. So its equation is going to be y equals the y-intercept. Because that slope is 0, it's canceling that mx term, and we're just left with y equals b, which is y equals 3 in this equation. Vertical lines are always going to intersect the x-axis. So we don't have a y equals equation anymore. We just have an x equals equation. And it's going to be x equals whatever the x-intercept is. Just like this is y equals whatever the y-intercept is, vertical lines are going to be x equals whatever the x-intercept is. So wherever our line crosses the x-axis, that's going to be part of our equation. We learned in a previous lesson that vertical lines have undefined slopes. And because we're never crossing the y-intercept does not exist. And we can shorten that to d and e if we would like. So again, vertical lines are x equals the x-intercept. Horizontal lines are a special equation that's just y equals the y-intercept. So with all that put together, we can write equations if we're given the slope or the y-intercept. We're just going to put it in that y equals mx plus b form. So we're going to substitute in this example, m is going to represent -2. So I'm going to say y equals -2x. And our b or y-intercept value is going to be that y value there, +8. So our equation, given the slope and the y-intercept, for this line is going to be y equals -2x plus 8. We could also do that with one of these special horizontal or vertical lines. We're told that the slope is undefined, that the y-intercept does not exist, but we have an x-intercept that happens at 7, 0. So given that information, I can tell that it's a vertical line. So we're going to have an x equals the x-intercept equation. So x equals 7 is our equation. So there's an introduction to slope-intercept form. It's one of the basic forms we use to write equations of lines.